Let's discuss Bernoulli's equation. Hello everyone. First, to derive Bernoulli's equation, we need a rearranged form of Euler's equation. Recall the identity for a smooth vector field A that A dot the grad of A is equal to the grad of a half times the modulus of A squared minus A cross the curl of A. Letting A equal to the velocity vector u, we then get that the curl of A is equal to the curl of u, which is equal to omega, the vorticity vector. So u dot grad of u is equal to the grad of a half times the modulus of u squared minus u cross omega. Also, for the gravitational acceleration, we can write that g equals minus gk, which is equal to minus the grad of gz. Therefore, Euler's equation that the partial derivative of u with respect to time plus u dot grad of u equals minus grad of pressure divided by density plus gz becomes the partial derivative of u with respect to t minus u cross omega equals minus the grad of pressure over density plus a half u squared plus gz. Now, let's consider Bernoulli's equation for irrotational flows. For an irrotational flow, omega equals the zero vector and u equals the grad of phi for some scalar field phi. Substituting this into the rearranged form of Euler's equation, we get that the partial derivative of grad phi equals minus the grad of pressure over density plus a half u squared plus gz. Rearranging this, we get that the grad of the partial derivative of phi with respect to time plus pressure over density plus a half u squared plus gz equals the zero vector. As the gradient operator includes partial derivatives of x, y, z but not time, this leads to Bernoulli's equation for irrotational flow that the partial derivative of phi with respect to time plus pressure divided by density equals a half u squared plus gz, which equals capital F of t, where capital F of t is some unknown function of time. Next, let's consider Bernoulli's equation for a steady flow. For a steady flow, the partial derivative of u with respect to time equals the zero vector. Substituting this into the rearranged Euler's equation, we get that u cross omega equals minus grad of pressure over density plus a half u squared plus gz. Taking the dot product with u of this equation, we get that u dot grad of pressure over density plus a half u squared plus gz equals 0, since we have the identity that u dot the cross of u with omega equals 0. As u dot grad is the directional derivative along the streamline, the term in the bracket is constant on the streamline. So we have Bernoulli's equation for a steady flow that pressure divided by density plus a half u squared plus gz equals b, where b is constant along a streamline.
As ever, thank you for watching.